Three, two, one. Welcome to Bellwether. Thank you for being here today. I am very excited to come back from my little podcast hiatus. We're coming right back into it with a very exciting guest. This person, we've been talking for a long time about coming on the podcast. I love the topic of neuroscience, and I think most coaches love the topic of neuroscience because it's a hot new topic. It's a bit of a buzzword in the corporate world. Everybody wants to know about the brain, but there are interesting aspects of it from the perspective of, how do you manage change? And as we're going through so much change right now in this world, both from how we operate on a daily basis to just fundamental economic changes to how we're going to be working going forward, or career changes and learning new things and making major adjustments, knowing how the brain works and how to utilize your brain or how it's holding you back is really good knowledge that you can use. I have strong feelings on neuroscience. I joke that I dabble in neuroscience because I read books on neuroscience. It doesn't make me a neuroscientist. And we see coaches do this all the time, and it's a little disingenuous where they just kind of, your hippocampus does this, and this is why you can't do this at work. And it drives me bananas because it's not really tangible, real stuff. If the people in the audience, I always joke, if the people in the audience wanted to know about the hippocampus, they would have become neuroscientists. So that's why I have my guest today. Sean Froudist-Walsh is a neuroscientist, and that's fantastic. And Sean has a lot of experience talking about short-term versus long-term memory, how to manage change using your brain to do that, how to learn as an adult. And that's really what we do as coaches. We help people adapt to change and how to learn new things and how to improve day to day and continue that evolution of whatever it is that we're doing. So that was me on a soapbox, but right away, I want to welcome Sean Froudist-Walsh. Sean, thank you for coming on Bellwether Hub.
Thanks for having me, Jim. It's great to speak to you again. I look forward to.
This is good. This is going to be good. Tell me about you. And you heard my little spiel about neuroscientists and everything else. Tell me about you and what you do.
So, as your listeners might have heard already, I'm from Dublin, Ireland, like your forefathers. And I got into neuroscience in a kind of roundabout way, I suppose. I am the son of two mimes, like the actors that don't speak.
Nice.
And I'm the complete black sheep of that family because instead of following in the silent family tradition, I went off and studied mathematics in college as a kind of a rebellious act. And
I'm trying to make a mathematics and mimes joke, and I can't. I'm going to come up with it. I'm sure there's one out there.
We can edit it in afterwards. So I was in college in my final year in Trinity in Dublin, and I still didn't really know what I wanted to do. And we had this guest lecturer from the Department of Neuroscience in. His name's Hugh Garvin, and he showed us this amazing data, and he explained to us how different parts of the brain were active when people were trying to focus their attention on different things, and how those patterns of brain activity were slightly different in people with ADHD, and how that was causing them trouble. And it was just a 1 hour class, but I was completely captivated. I remember after that class, I was on a bus down to my soccer match in South Dublin, and I couldn't stop thinking about it. I got into this state where I was completely oblivious to the South Dublin suburbs going by me, and all I was thinking about was, the cortex and brain activity and how these things go together and how the brains could change differently in these people with ADHD. And it was something like similar to what people call flow state, I guess. And that was my real introduction to neuroscience. And it was just 1 hour, but it was powerful enough to convince me to go down this route and change my life. And that was 2009. And so 11 years later, I'm still here. And I've gone down various different routes in neuroscience in terms of working with patients, thinking about how the brain changes itself, both in development and response to injury, and when we learn new things. And these days, I really focus on the details about what's happening in different parts of the brain and how they communicate with each other when we're learning new things and when we're remembering things, either for a very short period of time for a very long period of time. And I'm lucky that I get to do that. These days, I no longer do as many experiments, and I've been able to find a way to bring my math background back in. And I get to collaborate with wonderful neuroscientists around the world who are doing cutting edge experiments in all different details and aspects of the brain. And what I use my math skills for these days, as well as my neuroscience background, is to build very detailed computer models of the brain that try to solve tasks in a similar way to how our brain does. And hopefully that will teach us something important about how the brain works.
I feel like there's just a massive amount. Like when you think of whoever that mathematician was at Princeton, they made the movie out of it with Russell Crowe. Like when you take a look at this theoretical algorithmic, the brain is just this miles long algorithm where everything is connected. And that's fascinating to me because everything that touches your brain, everything from the food you eat to the sleep you get to the running that you do, all of these things are all connected in one particular way.
Absolutely, absolutely. And actually, you touched on an important point there that so many different parts of the brain are connected, and some part of your brain will affect the next part, and then that will go back and affect the first part again. And it's this big, complicated, recurrent circuit where you have all sorts of loops and feedback mechanisms. And that's something that we're really trying to build into our understanding of how the brain solves problems. Like a lot of computer models that are used in artificial intelligence these days, they just have a kind of a chain-like structure where area A passes the information onto area B and area C and so on. But we know in the brain that this information loops back, and there's some connections that skip, and then there's parallel streams and so on. And what we're trying to do is take advantage of our understanding of the brain anatomy and build that into our new models of how the brain might work in order to get a better understanding of what the different parts are important for and so on.
This is going to, I mean, this is the type of work that just fundamentally changes how people operate, right? It fundamentally changes. I mean, it goes all the way down to how students learn, all the way up to making a transition when you're 35 years old and regret becoming a corporate lawyer and you're looking to make a change and have to learn something new. Like all of this has some kind of relative impact to everybody listening to this call, whether you're raising a child or looking to make a change yourself.
Yeah, well, this is one of the things that is so rewarding about doing neuroscience research, is that, you know, you can find different angles to it just to keep yourself fascinated the whole way through. And it's one of those things that everybody has a connection with on some level or another. We all have a brain, or at least know somebody that does. And you know, there's so many aspects to it, whether you're interested in how we learn, how we remember things, or maybe you know somebody who's suffered a kind of a brain injury or brain disorder and you want to get a better insight into that. Neuroscience itself is very broad, and luckily now there's a lot of really smart people working on different aspects of it. Now, one of the difficult things these days is that we've had an amazing development of new tools in neuroscience that are able to, at least in animals, control the activity of individual brain cells. And we can also record in real time now thousands and thousands of cells as they interact together. But one of the challenges now for us, particularly those who are thinking really hard about the theoretical side about how this works, is how do you make sense of all of that information? Now that you can record from every cell, or you can record from many, many different cells at the same time in the brain, and you can have all of these different aspects of their structure and their genes and their chemical messengers available to you. How do you make sense of that and bring it down to something that can be useful, either for your own life or for guiding patient strategies and so on? So this is something that I'm hopeful that now that we are in the midst of a revolution of the technology in neuroscience, we'll also have a revolution of the theory and our understanding of the brain.
Yeah, and that's exactly where it's where the rubber meets the road that that's where I always am interested in is, theory is nice, but putting it into practice is going to be very subjective almost
Yeah,
for everybody that wants to take it and use it and do whatever it is that they want to do. Um,
absolutely.
so let's, if we can, let's get into some of the practical stuff, especially for learning something new. So I think of, you know, as we take a look at economic changes, industries closing, whatever it is, your business is closing, people are looking to do something new. We have to learn a new skill set. We have to learn new activities. Maybe we're making a change from an accounting job into a marketing job or something. What are some fundamental things that we can teach people on how to learn something new, whether it's something as simple as a new language or a new skill for work or, learning how to code or whatever it is?
Yeah, so there are some basic principles, I suppose, or sections of our knowledge that you can kind of group together. And they tend to be widely applicable. And I think they're just as good to know for parents who are thinking about how their kids should learn, or when we're thinking ourselves about how to learn another language as an adult or another instrument and so on. One of them is attention, basically. And the attention system in our brain can be broken down in different ways. We got to know when to pay attention, what to pay attention to, and how to pay attention. So how to think about our problems in different ways. And it's been shown time and time again that, okay, although it is possible to have some residual learning if you're not really paying attention to something, if you're really focused on what is going on, that is going to be much, much, much more effective no matter what you're learning. It needs to make its way and basically take over what your brain is consciously processing. That, I think, is basically the first principle. A second principle is that we need to uh, actively engage with the thing that we're trying to learn. So, for example, when I was at the beginning of college, my old lecturers, and they were very talented mathematicians, and they were highly cited, had created great theories in maths, and so on. But they were just writing everything on a blackboard for hours, and there were no questions, there was no interaction, or so on. But there have been countless studies showing now that you need to actively engage with what you're learning. So, and that doesn't necessarily mean that you need to be physically active, but you need to be cognitively active. So what you need to do is you need to uh, consciously reflect on what you're trying to learn. You need to think about different scenarios to test your understanding. Go, okay, I think this is how this worked. So then put that to the test. Go and that can work in different ways. That can be as simple as having a conversation with somebody about it and testing your knowledge about it.
It's making you're really just trying to generate something for your particular situation so that you can, I guess, tie something to it, right?
That's it. That's it. Manipulate the information and make it relevant to your life or relevant to what you want, how you want to use it.
Now, going back to focus and attention, uh, you hear the stats that we have the attention span of goldfish or whatever it is, so is there something for someone to work on their focus, right? Is it something just meditation, 5 minutes of silence will help you do that? Is it reading a long novel and long books? Does technology have this impact because everything comes in so fast, and we're swiping?
Mm,
From a brain perspective,
mm,
I mean, I read The Shallows. A lot of people listening read The Shallows and all those other books on what the internet is doing to your brains and all that stuff.
mm.
How do you find the focus in order to learn something new?
It's a really interesting question. And I think that a lot of the time people, okay, it's obviously different for people who have severe ADHD or for example, but generally people are able to focus some of the time. And if it's something that grabs their attention, is significantly interesting for them. And often the problem is when we're not able to focus on something that we should be focusing on. It could be our work, it could be some project that has value for us in the long term. But what's actually happening when we're losing our attention often is that we're making a decision to push our attention towards something else. And it mightn't even feel like a decision in the time, but that's kind of what it is. And a lot of these things that can be distracting for us these days, especially when we're at home and we're in front of a laptop all day, it could be Facebook or Twitter or Instagram or something. And the people who make these social networks, they're very intelligent. They know something about how the brain works. And what they do is they essentially gamify, or they turn your experience into like a little game where you have points. And in Twitter, that might be your likes or your retweets or the amount of people that follow you. And there are other types of metrics on the other social networks. And that gives you like a little hit of reward. And you start to create a craving for that. Now, I will say that not all technology is bad. Actually, there are people working right now on using the same types of principles in order to help you focus your attention on tasks that might be more valuable in the long run. And for example, there is a guy called Leader in Germany. What's his first name again now? Falk Leader. And him and his group are essentially gamifying lists of your goals and to-do lists. And the way that's going to work going forward is you're going to come up with a list of things that are very valuable to you that may be a long way away. And the problem with those kind of big, important things is often it seems like, oh, okay, an immediate reward of getting a like on Facebook or on Twitter seems so much more tangible and easier than working towards, getting a new job or whatever your long-term focus is. But the way, and this is a kind of a bias in the way our mind works, is that often we discount future rewards too much. And the way these new technologies are going to work is by essentially calculating the optimal amount of points or rewards to give you when you make small steps towards those big future goals. So I think methods like that and future technologies like that take into account how our brain works in terms of like the cognitive science, as well as use AI techniques to optimize them. They are starting to be little tools that people are going to be able to use and essentially to enhance their cognition and to enhance their attention on the things that really matter, instead of getting distracted by short-term rewards that don't really have long-term value.
That's interesting. So it's so saving for retirement, right? Long-term goal, nobody does it, and you're going to gamify it and use this AI system in order to incrementally get you there.
Exactly.
And you say it's to improve our cognitive ability, but doesn't that take away our ability to think by telling us what exactly it is we need to do? So how is it? Explain to me a little bit about how something like that is going to, and maybe we just, give up our hands for it and say, okay, if you can give me the path, I'll do what you have to do.
Well, I think it's a good question. So part of the thing I would recommend for anyone who's interested in these type of things is to learn a little bit more about how our brain works and how our cognitive biases work. And the fact is that we all have these. I've got these, you have these, even if we're read up about them. And what this is doing is thinking about ways to use our little routines that are shortcuts that our brains take all the time to our advantage instead of to our disadvantage. And in fact, even the fact of educating yourself, using a system like this, whether you use the app they're developing or you create a similar one yourself, that is already using like high level cognitive control. You're thinking about how thinking works and you're just using that to your advantage. You're going to use habits no matter what. It's just, I think about what this new wave of research is doing is trying to use a little bit of our understanding about how learning and habits and shortcuts in the mind work in order to use those to our advantage. And so I think, yeah, it would be good to look into what are the negative effects of such tools. But I think it's an exciting field and one that hasn't been explored enough yet.
I love it because everybody, I mean, how many books are out there to tell you how to create a habit? Nobody sticks with it, right? Some people say you have to do it for 30 days in a row, and all of a sudden it's just going to be this magical thing. Some people tell you have to focus on why you're doing it. But I could see the repercussions of this would be amazing in terms of saving for retirement, dealing with addiction over the long term, I mean, there's so many applications. I feel like this could be extremely helpful. Yeah, that's going to be interesting. That's going to give me lots of questions to ask for another podcast, I'm sure, but that's good. Good. Okay. So in order to learn something new, we need our focus. We need to generate, engage.
Yeah.
What else do we have to do?
I think there are a couple of other things that are really important. One is you got to make mistakes. You got to try things and you got to learn from your errors. And this is, there's quite a lot of research on this. So for example, people who study in a class, let's say it's a French class, if they are doing 3 months of French and they're studying really hard, they might feel like they've actually learned more if they only do one test at the end and they spend all of their time studying. But if you compare that to a group that has tests every week, okay, and what they've learned so far, the group that has tests every week will outperform them on the final exam hugely. And one of the reasons that works is that they're able to see after the results from the test of the first week where they've gone wrong and where they can focus their learning on the next time. There's also mechanisms in a brain so that when you're actually doing a test, you're forced to recall the original memory or the original knowledge, and that actually makes the knowledge stronger. It ingrains it more strongly. So I think learning from testing your knowledge and learning from your mistakes is really effective.
It's drawing on that experience. It's like touching a stove. People tell you it's hot, but until you actually feel the burn,
Yeah,
you're not really going to want to avoid it.
yeah. So hopefully you don't have to do that too many times. And I think the last really important thing is consolidation, and that is what happens when we sleep. And this actually is something that I was talking to my friend Javiera Oyarsun. She's a researcher in NYU, and we worked in Barcelona together years ago, and she studied memory and sleep. And really she was saying that you can't replace sleep during the week with sleep on the weekend. You can't really make up for it. You got to just do your best to get your full night's sleep in. And one of the reasons that works so well is that actually what's happening at a certain part of your sleep is that your hippocampus, which is one of the regions that's really important for these memories, is firing really quickly, and it actually replays the same pattern of activity that was active when you were experiencing things during the day. So you're actually, in a sense, recalling information during the day, and it's activating patterns of activity in the cortex and the outer part of your brain as well that were also active during the day. So you're recalling them. Your brain might even be doing some manipulations to test out, well, what happens if that would have gone a different way, and so on. And what you see is that normally we forget information on a kind of like an exponential curve. So it gradually gets weaker and weaker over time. But when we sleep, there's essentially almost no loss of the information from when we go to bed till the morning. So it's a really effective tool that for learning. And I think that's one that is, if we can all incorporate it into our lives, getting a full night's sleep, then I'd highly recommend it. It's also quite enjoyable. So.
I am happy to tell people to just take a nap and you're going to learn a lot of things. So that's fantastic, right? That's exactly. Instead of studying your textbooks, just go take a nap and you can kind of reset and it's going to be good for you.
There you go. So I think these kind of 4 things: paying attention, active engagement with the content, trying different things out, testing yourself on the knowledge and learning from your errors and sleeping on it. Those would be important.
Those are the big ones.
Big.
And is there anything, so I guess those would be the tasks to just increase this capacity to learn as well, right? I don't know if there are people who are just more inclined to learn. Like when I think of PhD students who go and study all the time, that will never be me at all, ever on this planet. Will that ever be me? But it's a different type of learning. I feel like I have a very different way to learn and a different type of learning. And so are people more inclined to learn certain ways and to do certain things, or is just, the focus, the engagement, the sleep, the mistakes, are those just standard ways to do it regardless of the type of person you are?
I think those will work for everybody. So there's a big controversy in the field right now. A lot of teaching courses have promoted the idea of learning styles like auditory and visual learners and so on. And there's a lot of controversy right now about whether there's actually evidence to support that. Certainly the evidence doesn't seem so strong right now. So these 4 things I think should work no matter what. And in terms of increasing your capacity to learn, well, I think there's a couple of things I'd say there. I would say, one, I would try to gradually change things, so like you can, get into the habit of learning new things. And once you've started to maybe work on your French and you figured out a system that works for there, then maybe once that becomes part of your routine and that's just part of your life now, well, then you might figure, oh, well, that worked for me with French. Well, maybe I'll try to do some of the same ideas now that I'm trying to learn the guitar, or I'm trying to, learn some information I need from my field. Also, a kind of a practical thing, particularly for memory, which takes advantage of this idea of testing yourself, is the idea of spaced repetition. So I don't know if you've heard of that before, but there's certain apps out there like Anki, for example, that helps you basically make flashcards. And you can have some information on the front and some information on the back. And the nice thing about these kind of apps is that it can be multimodal. So you can integrate auditory information, visual information, and those can act as kind of more powerful triggers for a memory for you. And the nice thing about this program, and other ones like it, you could even do it yourself with a calendar and a piece of paper, is that it will space out the memory tests. So you might have 2 on the first day, 1 on the second day, 1 4 days later, depending on if you keep getting them correct or not. And eventually it will go out to once every 6 months, once every year. If you make a mistake, then it will start to become more frequent. The test will start to become more frequent. And actually there's studies showing that this kind of spaced repetition will allow you to have the maximum chance of remembering the information as well as possible over the entire period. So this
I guess that goes back to just, you're drawing from your memory. You're pulling it back, and that's what brings it to the forefront.
You've drawn from memory, absolutely. And there does seem to be a little extra advantage of when you draw from your memory, which this kind of slowly making the increments bigger and bigger seems to work really nicely for when you want to remember information for a long time. So that's a kind of another little hack that certainly improved my memory. I use it now for languages, like you said. I also use it for my work in neuroscience. There's a hell of a lot of literature we need to learn. And, sometimes beforehand, when I was doing my PhD, I'd read a paper and, then I'd read many other papers. And then a month later, I didn't remember anything about the paper. And now I try to, distill key information that I think will be useful for me in the future. And I make a little flashcard on it, and I allow myself to be tested on it. And that's certainly increased my capacity to remember the neuroscience literature and also have these vocab languages and stuff. So
it's good for adults to remember that you always have to test yourself. Once you get out of college, you think the testing's done, but you're going to have to kind of, like you said before, gamify it so that you can continue to learn.
Absolutely. Yeah.
Before we wrap up, I do want to ask you, so when we first met, we talked about boxing and neuroscience. and how a fitness regimen and running and all these things are good for your brain. And I like to tell people that, but I have no basis for it other than the fact that I like to run and I like to box and I like to do these things. Are boxers the smartest people on the planet?
Absolutely. No, unfortunately, probably not. But there are some advantages, of course, to exercise in your brain. And this is a very active field of research. And one thing I would say is that it's divided into two camps, whereas most of the information we have, what's actually going on in the brain in terms of what are the chemicals released and what are the different neurotrophins, all these different kind of helpful little things released in your brain. A lot of that information comes from rodents, and a lot of the information we have of what happens in cognition and to our mind and to our mood comes from humans. And there's a lot of people working really actively in trying to put that all together. But it certainly seems that there are some really interesting things that happen to your brain when you exercise. So exercise is actually a stressor, and you release cortisol. And that might sound surprising at first, but what happens is you get a kind of a feedback loop. There are parts of your brain like the hippocampus and the front of your brain, the prefrontal cortex, that then feedback. And what happens then is when you put in a stressful situation after exercising, you have a less strong reaction to those stressful situations because of what's been happening in your brain during the exercise. It also affects the release of dopamine. Dopamine is a bit of a Goldilocks type thing, that you don't want it to be either too low or too high. You want it to be just right. And dopamine release can be augmented when you exercise, and that might be one of the reasons we see these cognitive benefits after a short bout of exercise that lasts for up to a couple of hours. Several people have shown that your attention and your short-term working memory improve. Other people have shown effects on decision making and so on.
And does it have to be intense, or can it be just something as simple as a 20-minute walk?
Yeah, so that's a really good question. I think that's an active topic of research at the moment. I don't think that's really been resolved. There have been benefits shown for all different types of exercise. It may be that certain types of exercise are better for certain aspects of how you think. And that's like something that really needs to be resolved in the kind of upcoming research. If people are willing to give a shot at digging into the academic literature, there's a really nice review from about 2016 by Basso and Wendy Suzuki. Wendy Suzuki is another professor in neuroscience and psychology here in New York. And that goes into a lot of the different mechanisms that are at play and a lot of the different effects of short bouts of exercise. But certainly at the moment, it doesn't seem conclusive, I would say, as to if one type of exercise is conclusively better. Now, you're talking about boxing as well. And one thing that is interesting about boxing, of course, there are negative effects. You know, if you get hit in the head, it's not great, especially if you get hit in the head many times over a long period of time.
Right.
Unfortunately, boxers with long careers are at a risk of getting chronic traumatic encephalopathy, or CTE, which is kind of a degenerative brain disorder associated with getting lots of hit in the head. But I will say that most people who do boxing don't have long professional boxing careers. And there are millions of people around the States and around the world who go in and they go to the boxing club and they get a great fitness workout, and they get a social environment with other people that they can be encouraged to do healthy activities with. And it's also a bit of a cognitive workout. There's some information, some results that suggest that maybe when you do exercise that is also a bit more cognitively demanding, where you have to think a bit more, it might have even more beneficial effects for your brain than if you're just running on a treadmill. So there's some effects that say maybe running outside might be better than running on a treadmill. Also, if you think about what's going on in boxing, it depends on if you're in a class or if you're working with somebody in a kind of a more realistic fight scenario. But if you're kind of sparring with somebody, it's a very high level cognitive game. It's what we call in behavioral economics and cognitive psychology. It's called game theory. So if I'm sparring Jim, and what I'm going to be thinking is, okay, how's Jim going to react if I throw a jab? And then how can I take advantage of how I think he's going to react? And then you're going to be thinking the same thing about me. So it's social, and there's many layers of cognition. So it's quite a demanding thing. And on top of that, you have this fantastic exercise. So up until the point you get punched in the head, I think it's a fantastic thing for your brain. After that, it's a bit more give and take. So.
Right. And that's good. I know, just from when you go running, it's one thing, but then boxing is just this whole different animal with using your arms, using your legs, moving around. And so when you had mentioned that, I love that just simply because I love boxing and all that. And it's good to hear that those are good people. So
probably the Irish side of you, Jim.
I think so. Yeah, it could be. So what's next for you? Is there anything that the listeners can do to support you? How could people find you? Give all of that.
Yeah. So right now I'm in this wonderful group of neuroscience researchers here at NYU, but in the next year or two, I'm going to be going out and starting my own research group, and it's really going to be focusing on mechanisms of short-term and long-term memory, and how we can take advantage of the new understanding we get in order to improve our memory and our learning capacity in regular people, but also going to collaborate, as I've done throughout my career, with clinicians in psychiatry and neurology in order to make some suggestions for potential new treatments or certainly better understanding of these conditions. And that's something I'd really like to dig into going forward and go after with the help of some very talented colleagues.
That's great.
How can people help? Well, like with any scientist, if you happen to be have a few dollars spare, we're always looking to run more experiments, or you can support our building of these realistic computer models of the brain that try to learn the same way our brains do. So if you're interested in that, or you just want to hear a bit more, get in touch with me. There are different ways to do that. You can email me, get me through my website, which is sfwneuro.com. And you can contact me on Twitter, which is just at SeanFW, which is SeanFW.
Fantastic. I will put all of that on bellwetherhub.com with this video so that you'll be able to access I want this to live forever, so that, when you get that $10 million grant, $100 million grant, $200 million grant, I can at least say it was on the website first, and that's where they got it from. We always wrap up with a book recommendation. Do you have a book recommendation that you can give?
Yeah. So I would recommend a new-ish book. I think you'd really enjoy it, Jim, and I think if the people that listen to your podcast enjoy thinking about learning, there's a new book by one of the top cognitive neuroscientists in the world, called Stanislas Dehaene. He's based in Paris, and the book is called How We Learn. And it has, I would say, 3 different sections. One is about how we learn as children, basically, and how our brain develops, and the type of knowledge that we have that's innate in our brain, and what we learn on top of that. Another bit is how modern artificial intelligence programs learn. And the last half of the book, which is, I think, really interesting, has a lot of evidence and practical tips for how to learn better, including the 4 principles that we talked about earlier. And that's solid evidence from one of the top cognitive neuroscientists in the world.
Perfect. I will put that on my list. I will read it. I love getting the book recommendations at the end of these, because my wife doesn't like it because it just piles up the books in the house, but I do get through them, and I love reading these books. So that's very good. Sean, this has been fantastic. Thank you so much. I know that a lot of people are going to benefit from this. I'm going to put more information on Sean on Bellwether Hub. You can learn all about him through his website and everything else. Sean, this was great. Thank you. I appreciate you taking the time.
Been a pleasure, Jim. Thanks for having me.
All right. More information on bellwetherhub.com. We have upcoming events, some virtual events. We got all kinds of things going on. So come check us out. And thank you, everyone, for listening. As always, I'll talk to you soon.